Hey, folks, welcome back to More Than a Refresh. Today we have Kevin Jernigan. He joined us earlier for an T3D session, and we just didn't quite get far enough. Kevin is former Oracle, former AWS, former MongoDB, former Google, and now with J4. And he has a particular interesting opinion on AI that's actually educated. Kevin, why don't you introduce yourself a little bit?
Yeah, thanks, JD. Yeah, I do have opinions. Well, we all have opinions. I have particularly strong opinions about what's going on in the AI world these days. But that string of companies that you listed is those were all database jobs,
Correct.
and so the obvious high level question is why am I talking about AI or working on AI when I've been working on databases for most of my career? Um, And yeah, I worked for Oracle twice actually, way back at the beginning of time for me in my career, and then did a bunch of consulting and startups, and then went back to Oracle in 2009, 6.5 years back at Oracle, then 5 years at AWS working on Aurora Postgres, then 2 years at MongoDB working on MongoDB Atlas serverless, and then a little more than 2 years at Google Cloud working on AliDB. Those are all databases either shipped, for on-premises use or managed database services in the cloud, but real high level. So I was doing product work in various database products and services for most of my career. And in all of those job transitions, I went from one job to the next where when I was leaving one job, I already knew what the next job was. I'd already, made the commitments and was ready to go. And maybe I took 2 or 3 or 4 weeks off and that was kind of it. Um, when I left Google Cloud last spring, I did that without having a job lined up and very much intentionally because I'd never really taken the time or space to look around a bit more, to think a bit more about what I really wanted to do next. Um, and so, I left at the end of March, early April, and didn't look around too aggressively at first because, you got to.
Summer.
Oh, summer's coming, but it was either going to be the same thing where I'm going to find a job real quickly, or summer's going to hit and I'm not going to find a job even if I try because things slow down in the summer. And so I decided, yeah, I'm just not going to look that hard. If something falls in my lap that I can't say no to, great, but I'm not going to go on a jobs hunt. Though I did look at a couple database jobs, various product jobs in some of the companies you and I know well. But I couldn't get excited about interviewing. Like I would have the preliminary interview with, hiring manager or VP of this or, chief product officer or whatever. And I couldn't get myself to go to the next round where, okay, we're going to set you up with 5 or 6 people and hey, let's go. And I just couldn't get excited about it. And it wasn't about the companies, right? It was about the the work. Um, doing the same because a lot of the work is the same work repeated. In terms of when you're working on databases, whether it's shipped as a on-premises database product or as a service in the cloud, you have to solve the same set of questions or answer the same set of questions. Or since that
Well,
was my
let's be
last.
fair. I mean, when you went to Mongo, I mean, the questions were the same, but the answers were vastly different.
Well, I'm not even talking about using the database. I'm talking about the stuff you wrap around it.
Oh, sure.
I
Yeah.
MongoDB still has to do backups and recovery and disaster recovery and HA and all that stuff. Their answers are somewhat different, but take one step back and the customer requirements are all the same. They need things not to go away. They need data to be correct and fast and all that. And who cares if it's relational or non-relational? They still have the same requirements. And I'd just been doing that repeatedly, and most of the time, you're fiddling with a little bit of details on the edges of the answers to those questions, or what Google calls the critical user journeys. Right? You identify your personas, your users, and identify their most important journeys using your product or service. And how do you make sure that they can do backups and do restores and point in time recovery and security in the right ways and authentication, authorization, all the stuff. And, you know, the jobs I was looking at was going to be more of that. And yeah, I'd get paid well and I could do it well. But I just wasn't excited.
Right.
And so I had to kind of go through a process to figure out what's not exciting about that. It's a job. You get paid. It's tough to get a job. especially these days, right?
Yeah. In left
Um,
field. Yeah.
yeah, and I decided I just didn't want to just take the next job I could get, right? Which is what I sort of had done in my previous transitions. Not that they were bad choices. It's just I didn't do a thorough job search. I was like, hey, I know
Or
somebody.
comfortable choices.
Yeah, well, I went from Oracle to AWS because I knew Mark Porter, who had been at Oracle a long time ago with me, and he was running a lot of the RDS team, and he was starting up this new Aurora Postgres thing, and I knew Mark, so that was an easy choice. And then Mark left and went to MongoDB,
Right.
and so I followed Mark to Mongo, and then I left Mongo and followed a bunch of ex Oracle and ex AWS people over to Google Cloud, and so all those transitions were, yeah, I know people. It's an easy to get the conversation started. Not easy, never quote unquote easy to get the job. You still have to go through the process and interviews and all that. But it was easy to get the process started. And I was doing that again. I was like, oh, I know people with these companies, and let me do that. Let me talk to them. But I decided, to take a step back, and then it's summer, like you pointed out, last summer. This whole AI madness is spinning up at the same time, and had been for a while. But I also didn't want to just go into what we currently call AI, which we should clarify or qualify that now. It's Gen AI or LLMs, right? Generative AI. And
Yeah. Well, actually, let me interject for a second here because you actually touched on something, and I know we're going to get to the AI, and it is an important topic, but you touched on something that uh, people who may see this that are younger in their career, everything he just described is the power of the network. And that's not a bad thing. And I don't think that Kevin. I don't think you were presenting it as a bad thing. I think it's actually a very powerful and good thing because you reached a point in your life now, and I'm there too, which is we don't get jobs by our resume. We get jobs by who we know, generally speaking. And that there's a certain comfort in that. And the reason I bring it up is actually because I was just Southern California Linux Expo. Just it just asked me to speak on this exact topic, which is essentially how you succeed, over 3 decades. Because a lot of people in our industry maybe understand, but completely abhor the power of the network and why it's important. So anyway, I wanted to devote for a moment on that because I mean, that really is, like you said, you brought up Mark Porter, and if I'm ever looking for a different job, which would be weird considering the founder of my company. But if I was looking for a different job, one of the things I would do is reach out to you and Mark Porter and Yoav and Jimmy and all these folks and be like, look, I'm available. You know what kind of asshole I am. What can I do for you? Well, it's a very powerful thing. Um, and more importantly, if you turn on open to hire on LinkedIn, don't do that. If you feel like you need to turn on open to hire for LinkedIn, your network is not strong enough. I turned it on as on a whim a couple of weeks
mhm,
ago. Did you
mhm.
see that?
I
Oh,
didn't.
I
But
turned it on because I'm not for once in the last like 8 years. First, I'm not traveling this season,
mhm.
so I was like,
Well,
hey,
that
I'm open for speaking gigs.
I did see that. I did see that.
Yeah,
Yeah.
and I turned it on. Oh my god! And we're talking 30 minutes, probably 500 recruiters. All of them like, I want your resume. How long have you been doing this? I'm like, if you looked at my LinkedIn profile, you'd know these are the wrong questions.
Yeah.
And
Yeah.
I blocked them all and turned it off. So don't do that. Just work on your network instead.
Well, it's gotten a lot worse in LinkedIn in the last couple of years, I think. I mean, I probably had it on in one or two of those job transitions, but that was 10 years ago.
A
And it
totally different
was,
experience.
yeah, signal to noise ratio is very different than now. Um, and so, yeah, it's tough. I mean, I just want to drill down on the networking point, though. A lot of hardcore techies, in my experience, make the mistake early in their careers of thinking that all I have to do is good work, and it'll get noticed, and I'll get noticed, and I'll get promoted, I'll get opportunities. That'll only take you so far if you don't talk about your work to your
Yeah,
peers, to your
you got to
managers,
promote.
to your skip level managers, especially. And somebody told me this. He passed away suddenly when he was at Oracle. Mark Townsend, you may have known Mark. But Mark Townsend said, when I'm in an elevator with, Larry Ellison, which would happen fairly often, randomly, um, I already had a list of things I wanted to talk to Larry about. Not talk to like in detail, but you got, the elevator
Yeah,
pitch thing of,
yeah, that's right.
oh,
Just the
if
five
I
minute.
run into Larry, what am I going to ask him about? Right.
Mhm.
And if I run into, another VP of this or that or the other thing, so have a list of things that you maintain and update for when you're going to, happen to, you know, have an unplanned interaction with somebody 4 or 5 levels above you in the org chart, and that
Well,
they're going to remember you later.
it's funny you bring that up because I've got kids that are in their early 20s, and the common thing I hear from them is, "But it shouldn't be that way." And my response to them is, "You're absolutely right. What's your point?" Because that is how it is,
Mm.
right? I it, y- Management and leadership should, in my opinion, understand the work. And I'm not saying that I need to remember how to code in C, okay? But understand the value of the work of the team, okay? And understand and know who is shining. Well, they forget that I have a job too. And it's more than just, oh, what is this, person doing? It's a lot more. It's how do I make sure this person gets paid, right? And so, yeah, I mean, it's not that you should have to be a salesman. It is that that's the way the game is played. Keeping your head down and doing your job is how you don't get fired. Promoting yourself, making yourself visible, building your network, whether it's internal or external, is how you get promoted.
Well, that's the kind of the minimal thing. Get promoted. Okay, great. But if you actually want to connect with people that you might want to go start a company with, now you
Well,
got to
that's a
network.
totally different level, though. That's
Yeah. But you got to
that.
network outside of your circle of people you work with, and try to connect across teams and figure out, hey, I'm interested in this, and see how you connect with other people.
No, absolutely, but I mean, I think what's important to recognize, you and I are different on that though, right? You and I are more people that want to do that. Most people, they want to be recognized for their work, be paid well, right, and be affirmed. They're not looking for people to go start a company with and get VC funding and make their billions. I mean, and maybe in the the atmosphere of their mind, but they also don't recognize what that actually takes.
Yeah.
You know, so
That's
anyway,
it's good that you don't know.
yeah,
It's
no,
people.
it's terrible. I mean, there's a reason why command prompt is designed the way that it is because uh, you know, I came into the market at the very beginning of the consumer internet. We're talking about 14 4K modems, that type of thing, and people hunted me because I knew how to launch ISPs and I understood the technology and I could talk the business side. And I went through several different, angel type situations, preliminary VC, and it just doesn't work for me, which is why we built the way we did. But anyway, let's get to your point because your point is why we're here. Because I mean, you and I could talk about this all day long. I mean, Mark Porter and I did 2 full episodes on this type of stuff way back in the day. Um, let's talk about AI and investment. I mean, it's the new hot thing. It's a new great corporate thievery. So what do you have to say about that?
Yeah, so, well, continue my journey past Google and
Okay.
past looking at database opportunities I wasn't excited about. And, we talked about this in the shorter podcast, but, I went back to think about what I studied in college because I have a degree in computer science, and, the options I had back then were pretty simple because it was way before the internet, the cloud, all that, and so you either studied databases and operating systems, or could study languages and compilers. If
Mhm.
you want to call that a tech stack, you can. Kind of the stack that was a real
It's
simple
part
stack.
of it.
And I wasn't interested in databases and operating systems. I was interested in languages, compilers. I learned lots of different languages like Prolog and Lisp and Ada, believe it or not,
My.
Fortran, COBOL, C. Yes, lots of C. C++ didn't exist. Object oriented didn't exist.
Yeah,
This is way before.
there's still lots of C.
Oh yeah, yeah. And we could do another podcast just on that. But point is, I was more interested in that level and that type of thinking about technology than I was in the underpinnings, the base layer, the bottom layers, the operating system, the database is right on top. Um, and I accidentally got a job with Oracle and went off in the database world for quite a while. But some of the classes I remember, some of the things I remember studying were things like rules-based expert systems and these things, this new idea called neural networks, because they were new back when I was studying them.
Mhm.
And machine learning hadn't really been coined as a term yet because it hadn't gotten that far. But those were much more interesting to me. And one of the classes I remember the best is a class where we were figuring out how to automatically parse English, grammatically breaking down sentences to generate code, right? So type in English and spit out a program. Does this sound
Sounds
familiar
familiar.
stuff?
Yeah, something about happening right now. Yeah.
Yeah, but we were doing it the way AI was done back then, which was what people now call symbolic AI. Symbolic, where you hand code the intelligence, right? Whether it's a bunch of rules like in the Lisa system that does medical diagnosis. So you literally have the medical experts hand code the questions and answers. Like you ask the patient or the doctor, what hurts? What part of the body hurts? Oh, my eye hurts. Okay, well, we're going to go down the eye section of the rules and off you go. That's what most people now call symbolic AI, where you the human code in the symbols and the rules and all that. And that's how we were doing this. Hey, let's parse English and generate code. And the idea of using neural networks and machine learning just didn't make sense because you couldn't brute force anything.
Right.
I mean,
We just stuff wasn't fast enough back then.
wasn't even close. You couldn't even consider it. You couldn't conceive of it. You could look at Moore's law and say, yeah, eventually we'll get there, but eventually for us was 30 years later. It's like, you know, it's a kind of a silly conversation. So back then, the only way you're going to make anything work with behave with any sort of intelligence, any computer anyway, was not by brute force scaling up neural networks. It was by symbolic AI, hand coding various things. But that was the stuff I found interesting. Then I went off to the database world for a long time. Still paid attention. You might remember, you might not, the fifth generation project from Japan. So in the
Vividly.
70s, late 70s, early 80s, Japan, who was the dominant economic force that was threatening,
Mhm.
the USA's dominance on
Those
the,
damn little cars.
yeah, they're kicking our ass and making better cars and better, Walkman and better appliances and all this stuff. The government of Japan said, hey, we're going to build the fifth generation of computer technology. We're going to build AI. We're going to create AI. And it's called the fifth generation project. And that freaked out a bunch of people in the US technology industry because they're like, oh crap, Japan's going to beat us. All right. That didn't go anywhere. I mean, we don't hear about Japan dominating an AI in any way, shape, or form today.
So now, hold on. Now the question is, excuse me for a second here. And sorry, folks. I'm standing in front of a wood stove, so it's a little warm. The question is, uh, wh- what did we do about that? Right? What's the underlying? Why didn't they kind of achieve what they wanted to achieve? Was it the socioeconomics of Japan, or was it the brute force of the United States?
Um, well, brute force wasn't possible back then, not the way we are seeing it now. And so the approach was all just let's brute force symbolic by having lots of people try to write, rules based stuff. And it just didn't get far enough, didn't get nearly far enough. We'll come back to that in a bit when we talk about, Gen AI or LLMs. So Japan tried that. There were some competing efforts in the US. None of them went anywhere. We went into an AI winter, as people call it. Because the whole concept of AI was coined at a conference at Dartmouth in the 50s. That's where they invented the term. So we've been working on AI for now 70, 75 years. How far have we gotten? Right?
So, well, never far. It's just faster. Right? I mean, I think this is my frustration with one, it's not AI. There's nothing intelligent about it. It's a smarter dumb search engine, right? So that's part of the issue that I have is that we, and although we are accelerating, right? I think that's true. Generally speaking, I mean, unless there's something happening that isn't publicly available, which is obviously certainly true. Right now, it's just a smarter, dumb search engine, and it can do new things, and some of it's really scary. Especially its deep fake capability and auto generate. I even just using Google Gemini, I was able to generate what a 1 minute clip or a 15 second. I don't remember what the limit is. I just said create a clip that does X Y Z, and boom. And unless you're really paying attention to it, you can't tell if it's a clip in passing. It looks real.
Yeah. Yeah.
So, anyway, please continue.
Yes. That was happening, and I was paying attention even when I was in college, because that I bought a book on the fifth generation even before, I think, in high school. So I still have it on my bookshelf.
So you're a
So I was
nerd.
paying attention. Yeah. Sometimes. But then, I grew up in the East Coast. I went to Harvard, so I was in Cambridge, Massachusetts, got a job at Oracle, moved to San Francisco. So now I'm totally different world, paying attention to database stuff, not AI anymore. And I lived in San Francisco for 30 years before moving back to the Boston area. But, I occasionally saw stuff happening in AI, but not that much happened, or else we'd be much further along in the last 70 years of research than we are. Right. And so what happened somewhere along the way is machine learning came along, and Jan LeCun and a few others invented deep learning, a deeper, more intense way of using neural networks and machine learning to get further and down one path, a particular path of figuring out, can we take a data set and learn from it, and then take a test set and see how well we learned on the test set, and then apply it to real, input that we haven't learned from. Like recognizing cats in pictures is,
Hmm.
classic example. Or if you're familiar with the MNIST data set.
And that one I'm
MNIST,
not.
yeah, NIST is National Institute of Standards and Testing, I think. MNIST is a data set that Jan LeCun put together in conjunction with NIST, that is just optical characters. So 0 through 9 digits, handwritten, right? 60,000 samples that you train on, and then 10,000 test samples that you see how well you can identify after you've trained on the 60,000. Right. And it's a classic thing. It's been around for 20-ish years at least.
Oh,
And
this is
lots,
interesting.
yeah.
Because I saw it's from Google recently about how they were showing that CAPTCHA,
Mhm.
identifying optical, pictures, people can identify. They just showed a specific example, but it was like people can get this capture right like 8%, but machines, bots, it's like 93% now.
Yeah. Yeah.
So and it is obviously in relation to spam and how what are the next generation of preventing all the evil people out there from taking your stuff. But it was an interesting correlation there.
Yeah. Yeah. So I guess the reason I bring up MNIST is just, it's a classic example that people have built all kinds of different ways of training on input, and then using a known set of test input to see how good your training is. And that's what all these machine learning models are doing. They train on a bunch of data, and then you see how good they are at answering real world, input. That's what a large language model is. Large language model is a specific type of machine learning model. It's a language model, and it's large. It's large because you give it a huge amount of input and build a huge neural network. Now, a neural network is just a really simplified simulation of the human brain, where you have nodes and connections between nodes, or neurons, right? Now, in the human brain, each neuron can be connected to a whole bunch of other neurons. Like, can have lots of dendrites, lots of connections, and the connections can have different weights, different chemistry, et cetera. So a neural network
I mean,
simplifies that.
in a database term, and if this sounds completely dumb, don't be afraid to be like, no, JD, that's dumb. But in a database term, it sounds like a B tree.
Yeah, but it's not hierarchical.
I see. Okay.
It's more like a graph, right?
Okay.
Nodes and edges, but vertices, whatever. But each connection between two neurons has a weight.
Okay.
And what are you really representing is the relationship between the concepts that each neuron represents. So in LLMs, you ingest a bunch of text, language, right? Um, and the text comes in a certain order because you write a sentence in a certain order of words to make it make sense. And so neural networks, or sorry, LLMs, parse that into, actually, they even chop the words into smaller pieces. So subsets of words, and how tightly or loosely are they connected to each other? And if you ingest enough text over time, you build a giant neural network of nodes representing tokens, as they call them, and the weights between them, or parameters. And so when you say large, there's billions of parameters in these systems, and some of them are getting close to a trillion parameters. And so that's what is happening in a large language model. You ingest a bunch of text, you do the statistics, you do the math on the likelihood of the word sky coming after the word blue, or the UE coming after BL inside
Mm.
a word. You do all that math, right? Insane amount of math, right? And now you have this giant neural network with a bunch of nodes and weights. And then you give it a prompt, like you ask it a question, which is really just a string of words. And it looks at the probability of what word should come after that string of words, right?
Okay.
Because that's what it's
Yeah,
done. It just,
no, so my mind is just going off on the idea of we are all, I mean, if you take it from a scientific perspective, we are all essentially ones and zeros. We're all math. And it's just what math we haven't discovered yet. Right? If you think about, because I mean, if you think about it from a theological perspective, right? Without getting entirely too philosophical, what is God, right? And my theological friends, I'm not questioning your beliefs here. I'm just saying that what is God? Well, God is what we cannot explain. And so, if you go back through the scientific history of the Earth, there is a point that we reach where we cannot explain. So we just say, "Well, this happened." We think. But what you're going forward, what you're saying is that we're getting to a point where we don't have to think. And that's
well,
a little terrifying.
that's one of the negative impacts of using a large language model, a chatbot, um, to think for you, to write things for you, to analyze things for you. It might feel like, hey, I mean more productive and all that, but your brain is being flattened into just a twitching amoeba, you know?
A true or false result,
Yeah,
essentially.
yeah. Yeah, you're not learning nuance, you're not learning to analyze things yourself, you're not learning to cross-pollinate across things that only you and your personal experiences in your life would be able to do in exactly the way that you would feel it and understand it, right?
Well, and from that, from an artist perspective, and I don't mean art necessarily as paint, I mean as someone who creates, you're removing discovery and you're removing passion and you're removing the things that make a lot of what we as humans, as meat puppets, are great about.
Well, the big thing that's missing in LLMs, one of the big things is what you're just saying is that LLMs can only spit back at you what they've been trained on, and they will interpolate between points in their network. So if they don't have an exact match for how they want to answer, they'll make something up in between. They'll interpolate.
Is that what they're calling hallucination, or
Yeah, and I really object to those terms because hallucination is anthropomorphization of the technology and making you thinking that it thinks and it's choosing to do something. It's
right? It
just
doesn't
math.
think.
It's
Okay.
just a big pile of numbers. And as much as you might want to say, so is my brain, I object. I'm not sure why. I
Well,
intuitively
no,
object.
so one, I think we object because if that is truly our brain, then what's the point? Where
Well,
eventually
and
we're
so
going to reach a zero sum game, right?
well,
There's
we're
no
getting into the God, mystical, magical thinking thing.
yeah.
So if it can't be reduced to a computer, then what are you saying is going on there? And you get into that whole cycle, but nobody has yet been able to even start to define consciousness, for example.
Right.
And that's the same question, actually. So what I was going to get to, though, that's really missing the LLMs, they can only interpolate between what they've been trained on. They can't actually come up with new ideas, right?
So they
And
don't
so,
think, they
no, they don't think
research.
at all. They don't have what some people call a world model, which Jan LeCun left Meta. to start a company focused on world models. Other AI researchers are doing similar things like Mira Murati. What's a world model? Well, it's an understanding of how the world works, like physics, like what happens if I pick up my foot and I'm going to fall down if I don't have balance. Simple stuff like that. If I touch the, you know, hot stove, I'm going to burn my hand. And that's going to hurt.
Yeah,
And
no,
then I
I
got
mean, I mean, all
common
due
sense stuff.
respect, all due respect to the big minds that are doing this, because obviously, I mean, they are. But it removes, if we cycle it down, we're going to do this. If we cycle down the math, ones and zeros, okay, because that's what all math is. We're removing the things we don't know, right? Unless our computer program can return and say, this LLM can say, I don't know. It shouldn't guess. Well, this isn't hypothetical physics or theoretical physics or whatever. This is, there are things where, like, this is a good example. You said, if I'm on one foot and I balance, how come I don't fall over? Well, the basic answer is the same for everybody. The complex answer is not.
Mhm.
And because it could be they have better inner ear usage. It could be depending on where they are on the earth. It could, because of gravitational pull. It could be, oh, my favorite is, you hear these stories of these individuals that were born without large portions or even an entire hemisphere of their brain where they shouldn't be able to learn how to do something. And then
Yeah.
they do.
Yeah. Well, that's because we don't really understand how human intelligence physically works, right? We think it's all in the brain. And like there's experiments they do with, I think, flatworms where the flatworm learns some basic behavior and then you cut off its head and it grows a new head and still remembers the behavior. Yeah.
Terrifying, but yeah.
Yeah. Yeah. But
And now the flathead one overlords are going to come get us, and no matter what we do, we're
well,
going to learn from it.
but the point being is clearly there's more going on than it's all in the brain, nowhere else in the body.
Right.
Unless you want to get mystical and say it's stored outside the body in some other place that we haven't discovered, right? And you can do
Well,
that, but that's hard to
you don't
test.
even have to get mystical. I mean, although that would be the default answer, the scientific answer would be it's energy of some sort,
Yeah, yeah, yeah.
right?
And so, anyways, that, big part of what's missing for me in LLMs is it just the idea of coming up with new ideas, figuring stuff out. That's what I was referring to earlier by your personal experience in your life and reading and learning and doing different things, and then you have some challenge in front of you. The ideas you're going to come up with some of them are going to be completely cockamamie and useless, but some of them are going to be interesting, but they're all driven by the fact that you've had your specific experiences and you as a human know how to come up with ideas that are outside the box, if you will. Right. And LLMs aren't able to do any of that. They don't understand anything. They certainly don't understand reality. Like the reality, you can argue, oh, there is no reality and it's all perspective based. Well, yeah, but there is a reality that we
What?
generally share.
There's a base. Yes, there's absolutely a. Although I've met some people, you really got to wonder what the reality is. Generally speaking, there is a reality. Before we started this recording, you mentioned that you took issue with how much money is being funneled into LLMs. And I have my own reasons, mainly because a large amount of the money, well, I mean, you take someone like Anthropic, who declares they're a public benefit corporation and then loses a multi-billion-dollar lawsuit because they're actually just thieves. If they didn't call me out on that, but I received the little piece of paper that said, "Yep, they're thieves. Come claim your money because they stole my book."
I see. Yeah.
And so, there was an article that just came out about how did the LLM, they don't call them LLMs, but how did AI get so far so fast? And they point blank said because Silicon Valley bought a bunch of books and scanned them in. Now that's not necessarily illegal, that part, right? Because like they legally purchased the book, they scanned it in. As long as they're not distributing the LLM, I don't know. I'm not a lawyer, but there's a fair use argument, I guess.
Well,
Um,
they've promised that the books aren't in there, right?
oh,
They
that's
swore
like Google saying they don't listen.
well, no, 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 but, here's what happened. So they swore up and down, OpenAI and the rest of them swore up and down, we don't have word for word any of these books in our systems. And then people went off and said, yeah, but all I got to do is give it like the first few sentences of Harry Potter and it spits back the entire effing book. So it's in there somehow. I know it's not in there word for word, but in those billions of parameters and the weightings and all that, if I give it the right prompt, it'll give me the whole book.
Well,
So
that's actually what I was going to say. Based on your description, it's just a program waiting, so it
it's a different
this message sent to
representation.
you. Yeah, but it's still the book. It's still in there. It's just not in a sequential paragraph.
Yeah, but if you prompt it the right way, it'll spit out the book. And that's what was demonstrated like in the last month or two. And so all the claims are saying that, oh, well, we don't actually have the original texts. If you prompt them the right way, you can get the original text out. So you just, knowing your book, you could probably do that. You could probably prompt it the right way with the first paragraph or two, and you could probably get most of your book out.
Yeah, especially because of the topic of the book, right? It's not
Yeah.
that hard.
Yeah.
All
So
right,
there's that.
so
But the money isn't being spent on that.
what
Obviously.
is it? What is the gripe here? What's our hook of angst? Because
So,
people just love our hook of angst.
well, so, I got to go back 20-ish years when people working hard in academia and in research on machine learning models looked forward and saw brute force coming because computing was going to continue to get faster, bigger, cheaper, and said, yeah, but it's just going to have these limits and it's going to have these flaws and limits in terms of how far you can go and how capable the models will be. And the flaws are not bugs, they're features. Like I hate to use it, but hallucination problem is a feature of the
Mm-hmm.
algorithm, not a bug that you can like, remove. Um, and so, hardcore AI researchers said, that's a dead end. We're not going to get to, true AI or AGI, as people call it now, artificial general intelligence. We're not going to get there. That didn't stop Sam Altman from saying we were going to get there when he launched ChatGPT or GPT-3. Right? He launches this chatbot and says this, we're going to scale this up. We've discovered laws of scaling, which simply meant that if we put more text in, it's going to keep on getting smarter. If we put enough text in, it's going to be smarter than us. So they thought they discovered laws of scaling.
You
And
can't you
so,
can't
so,
exceed the intelligence of humanity by using the source of intelligence of humanity.
but is language even that? It's not, I would claim.
Sure,
It's not
fair
even a
enough.
source of intelligence. It's just words. It's not, there's a lot of our intelligence that is not language. It's not words,
It's a
you
lot of
know?
intelligence that's not intelligence. Just look at the mass media.
Well, so So, but let's say you fully bought in, right? Okay, great. We're on the path to AGI. And if you suspend disbelief, we're watching a Hollywood movie now, suspend disbelief and say, okay, AGI is a great thing for humanity if we can just get there. Um, we need to scale the models to get there. Well, how do you scale them? Well, by ingesting more text. So let's
Mhm.
get our hands on every piece of text we can. I know we might be violating some copyright laws, but humanity will thank us, all right, eventually. Um, One thing we didn't talk about is what it takes to process a prompt. So remember, we have this giant neural network of all these, nodes and parameters and weights and all this stuff, right? To answer a prompt, you have to touch them all.
Oh,
So what does it cost to answer a prompt?
a lot of rural land.
Yeah, a lot, right?
Yeah,
That's
that's where the whole data center argument comes from, right? So,
yeah. So if I have to scale these things, I need to build giant data centers because the only way I'm going to scale them for general use is I need to be able to handle a whole bunch of prompts going at the same time. Right? Millions of people typing prompts at me, throwing prompts at me all day, either directly through a chatbot or indirectly through various applications that use MCP or other protocols to bang on the AI models, the LLMs. Well, guess what? They're banging on all the parameters all day, every day, 24/7, 365, melting down the GPUs that are servicing all these prompts because they have to touch every parameter, every prompt. And that's a feature, not a bug. That's the way these things work, right?
well,
So they have to raise trillions of dollars, literally, to build data centers big enough to meet the projected demand that they have to get to have any hope of making money. because of how expensive it is.
So the economics of this aside, there are only two people in this world that are alive today. I won't mention one of them, but I'll mention the other one that scare me when I look at them. And Sam Altman is one of them.
Mm.
He has a presence that that it's not even charisma; it's beyond it. Right there's something like I look at him. I'm like I won't use ChatGPT. I refuse. I'll use Gemini. Right. And I'm not saying Gemini is any better than ChatGPT. I honestly don't know because I do not use ChatGPT because the guy terrifies me that much.
Yeah.
And
Well,
everything that you're saying is just reinforcing that.
well, I mean, I don't know Sam. I've never been in the same room with
Sure. And
him,
neither do I. He may be a great guy. He seems like an
but
egomaniac, but
all we,
still.
all we can do is measure his statements and his actions, and
Right.
you know, and et cetera. And he's had to back way off. He's no longer saying we're on the path to AGI, but I still need to build trillions of dollars of data centers to satisfy the demand. But here's what doesn't actually work. And I was watching CNBC this morning, and they were saying this, and I was like, you guys understand that what you're saying actually doesn't make sense? They were saying, well, you know, the pure AI companies, meaning the ones that just do Gen AI, so OpenAI, Anthropic, Mistral, a few others, um, and they were focusing in on OpenAI. They said, well, they need to say triple their capacity because that'll help them triple their revenue. And that's how they're going to make more money. And I was like, wait a minute. So right now, for every dollar of revenue they generate, it costs them like $5 to service it. So if you triple both of those, what do you get? You get $3 of revenue and $15 of
Right.
it. The
It's
lines
basic,
diverge.
it's basic business economics. Right? How it works. I don't understand.
It's asinine.
So,
it's
so
it's absurd.
I mean, both are basically, dude. And let's be honest. I mean, our issue with this is the scale because every single VC funded firm does this, right? Enterprise DB was going to destroy Oracle, right? And I'm not knocking EDB. That's what they said they were going to do, and they've come nowhere close. And have had to be bought out multiple times for private equity to continue to operate, right? Well, and frankly, I mean, from my very real world, the same thing happened with a company called Great Bridge back in the early 2000s. They were the first Postgres company, right?
Mhm.
And they were venture funded. And I called them as command prompt and said, "Look, I just need a tier four. I doubt I'll ever talk to you. We're already servicing our clients, but you guys, you've got the core developers. We just want to, have a relationship." They won't even talk to me for less than 15 grand. Like 9 months later, they're out of business, and I'm still here in 2026.
Yeah, yeah.
So, I mean, if I'm being fair, that's all they're doing. And some of us say, "Well, a lie is a lie," but some of us recognize that everybody lies. It's just the scale that's scary.
Well, yeah, I that's the problem I have. If you aggregate what the biggest, pure play Gen AI companies have said they need, it's about $7 trillion of data centers by 2033. All right. And so $7 trillion of data centers is about a continent's worth
And
and about
who's
an
going to pay
ocean's
for
worth.
that?
Well, so that's what's happening. We're going to run out of VC money pretty soon in the next couple of years because OpenAI, for example, keeps losing money at larger scales. So they keep on having to raise more to cover their burn rate. Again, if you believe CNBC, it's 3x and 3x. So the lines keep diverging. Their gap is bigger, not smaller.
Correct. That's correct.
And if they decided to charge more or charge enough so that they were just break even, they would lose most of their customers who would say that's way too expensive.
Well, and speaking of OpenAI, I mean, I don't know about Anthropic, but they're competing against, and I appreciate that Microsoft is helping them, but they're competing against the largest knowledge company in the history of the world, right? And people can complain all day long about everything that Google does wrong. It's real hard to complain about what they do right, and they are very, very good.
Well,
and they'll already make money.
the challenge the single purpose AI companies have is exactly that, that Google and Microsoft and AWS and maybe even Oracle maybe can fund their AI businesses at a loss, right? They can they can afford to lose money for a long time on because they have the same cost problems. They're trying to address it by, Google's using their TPUs, which cost them less than paying NVIDIA for their GPUs, but it still has to touch every parameter, every prompt. I mean, it's still grossly inefficient. Um, Still nowhere on the path to AGI or brain scale AI, right? And so, but they can subsidize it for a long time. What the only way OpenAI and Anthropic can subsidize it is by continuing to raise more money. I mean, SoftBank's thinking of putting another 30 billion into OpenAI, according to an article I read this morning, just as another little hit point. Just a quick 30 billion, you know?
Yeah, well, let's analyze that for a second. Okay, now certainly, the financial industry in the last 15 years has proven that their goal is not actually to provide profit for humanity; it's to provide profit for themselves. And good or bad, that's just what it is. Um, and but they're also not stupid. Mistakes happen. I mean, like '08 was obviously a huge mess up. But SoftBank to be like, well, here's 30 billion. That's not a small amount of money, right? And for the like you said, just be like, yeah, we're thinking about putting it in there. What is it that you think that they know that we don't know? Because I'm not going to do it just on a 5-minute PowerPoint.
I think they have a couple problems. They don't have anywhere else to put it. Um,
I'm available.
yeah, but they can't invest a small enough amount.
Right.
When you have that much money, you can't invest, 10 million here, 10 million there. It's too many to manage, too many little things to manage. They have to put big chunks down in a smaller number of investments. It's just not worth the trouble. I know 10 million is a lot of money, but to them, when you have 30 billion,
Well, no, I mean, it's all scale again, right? I mean, and you're right, because let's say they need to, in your example that you're giving, they need to write off as an investment $30 billion. If they do that in $10 million chunks, there is no return on investment.
the
Because
overhead of
even if it,
managing it is too high. It's
yeah, that's
crazy.
what I'm saying, is that even if all 10 million, each 10 million returns profit, the management cost alone and all the various laws and all that stuff, there will be no return.
Yeah. Yeah. And so that's part of it. They have too much money to invest in small pieces. Um, and so I think, I don't know what their competing choices are, right? Could they put some money into Anthropic? And maybe they are doing that. Maybe they're hedging it all the way around. What isn't happening is investment in other ideas until recently, right?
Okay,
Meaning,
so now this is interesting. What is the other idea?
well, no, there's plenty of other possibilities, any other ideas for AI, I mean,
Oh, okay.
right? Everybody's investing in LLMs because everyone's investing in LLMs. It's a lemming, everybody's sticking with the pack thing. And that's how VCs have always invested. They all, we all invested in social media at the same time. They all invested in, data management for enterprise at the same time. They kind of do everything in packs. And so they're all investing in LLMs right now. They say they're investing in AI, but it's really just LLMs. It's kind of like, the old story about the drunk guy looking for his keys he dropped in the middle of the night, and he's looking under the street lamp. And, why is he looking under the street lamp? Because that's where he can see.
That's where you can see.
Not
Yeah.
where the keys are necessarily going to be, but that's where he can see. And why are they investing in LLMs? Because that's where they can see how everyone else is investing. And so what's being starved out are other approaches, or startups, little startups that might, come up with very different ideas that might actually work better. And so that,
Are
yeah.
are you seeing it? So it's funny you bring it up because I'm not seeing this in the AI space, but I'm seeing it in other startup spaces in my world, where they have good ideas, but they can't get any funding because everybody's focused on
Yeah, that's what I
LLMs,
mean. You can't
AI,
get funding. You also can't get talent.
right?
because the talent wants to work for the LLM companies because that's the hot space, right? And if you're not doing LLM stuff, then the talent that's coming out of colleges, PhD programs, et cetera, doesn't have a lot of real world experience. They hear the buzz and they see the large offers that people get from the
Yeah, it's
LLM
like,
companies.
and let's not forget the paychecks. It's not just what's interesting.
Yeah. Yeah. So that's what the big concern there is, that AI research is being completely distorted into one space that was known to be a dead end more than 20 years ago. Yet that's where the money's going.
So outside of Skilled, have we seen this at any other time? Right. So you brought up social media, but social media wasn't new, right? I mean, AOL, CompuServe, Prodigy, and even BBSs before that, right?
Yeah. Yeah. Well,
And it
right.
didn't starve out other markets. Is it the scale of this that's causing the problem? I mean, like
Yeah.
you said,
Yeah.
SoftBank's 30 billion.
It's because of how inefficient LLMs are, both to build, to train one, and but even more importantly, to run them, that they need so much money. And since there's a cynical view of this, that nothing else, Silicon Valley hasn't come up with a real growth idea in a long time, a hyper growth idea.
That's
And this is
true.
the only one. So that's where all the money is going, is the only thing that seems to be like a hyper growth idea is LLMs. So what
Well,
else
and
is,
when we're talking about a hyper growth, we're talking about really a hyper return,
well,
right?
that's what I mean. I mean, the VCs need a 10x home run to
Right.
make all their other failed investments, pencil out. That's how their business model works, right?
So
And
how does this affect you with what you're doing with J4?
yeah, so J4, um, I mentioned this concept a few minutes ago. Our mission is, and our vision is, to build the tools for brain scale AI. And what we mean by that is AI that can run like in the scale of your brain, or embodied on the edge, or in a vehicle, or in a humanoid robot, and doesn't need a connection to a giant data center. So how do you get to brain scale from where we are? You know, your brain uses 20 watts at
Well,
most.
yeah, but I mean, that there's an efficiency model there, right? I mean, sure, we use 20 watts, but I mean, we don't even understand really. I mean, I'm a whiskey because that's a much broader discussion. I mean, you're right. I mean, from an electrical or an energy, I shouldn't say electrical, but from an energy perspective, 20 watts is nothing. I mean, I don't remember if I mentioned, I'm 100% off grid.
Mhm.
So I very much understand energy consumption because otherwise my wife can't do the things that she wants to do and she gets busy.
Yeah,
And you're
yeah,
like, our fridge, well, actually, even this is a better example. So we have a toaster oven. Toaster ovens use a very similar energy consumption as microwaves.
yeah.
And
Okay.
what people don't realize is that microwaves, a good one, will use like 1100 watts, right? My toaster oven uses 1300 watts. Well, that means that my toaster oven and my Xbox, if they're running at the same time, are going to blow a circuit,
Yep.
right? And so, and now if we take that number, that's a very common thing for a household to do. Someone's on an Xbox, usually me, and someone's using a toaster oven, usually Amanda. And if we run those at the same time, there's a chance we might blow a circuit. But our brains are working on 1% of that.
Yep. And yet they can do a lot more than a toaster oven or an Xbox.
Yes. How are
So
you, not you, Kevin, but you, J4, how are you? I mean, if that's your goal, and we know it's going to take, you know, SoftBank's 30 billion to get started, how are you getting started? Because it's a well, it's not a new idea, but I assume your approach is a novel one.
yeah, we think so. But our approach is not, something we came up with in the last 12 months, right? It's been built by, our founder, Jeff Glickman, over a lot longer period of time. Um, and there's multiple innovations that are needed. All right. Your brain is not just a simple flat space of neurons. Your brain actually has 3,500 different types of neurons. Just to get started with, the neural network model is
Well,
naively,
yeah, okay.
and we've discovered recently that there's these other cells in your brain, not neurons, that are part of your brain's computation, if you will. Nobody's even figured out what those cells are yet.
Do we have
Glial
a name
cells.
for them?
glial cells,
Glial cells.
Glial,
Okay.
glial or glial. I don't even know how to pronounce it. Point is, there's a bunch of stuff we don't even understand. And so if you think neural networks are going to get there, you're missing like 95 or 99% of the complexity. And so if you're going from a model of let's simulate the actual architecture of the brain, you're a long way from anywhere right now. Um, but we're coming at it from a different perspective than that. And some of this comes from work that J4 was doing before I joined. If you look now, the website still talks about what we were doing. J4cap.com talks about
Mhm.
J4 Capital. We were using a fund in the market to test out and develop various AI ideas that Jeff started that effort probably 20, 25 years ago. And ultimately, everything he did with his experience in AI over the last 50 years, and he holds about 50 patents across a bunch of domains, including the foundational patents for machine learning that he filed in the late 90s that all of OpenAI and the rest of them are based on. So
So he's
Jeff,
making feed. 90s they'd be expired now.
yeah, yeah. But point is, he filed those patents. He came up with a lot of the foundational stuff, so he knows what he's doing. Which is my point. Um, and all the work he did with the fund kept on coming up with the same category of answer, which is a very specific branch of math called stochastic partial differential equations. Yeah, don't ask me to tell you exactly what those are.
Well, somehow I feel like this is more than moving the decimal to the left.
Yeah, yeah, yeah. So, you may remember calculus,
You
and
sure?
then after calculus, you learn differential equations. And
Right.
then after that, you learn partial differential equations. And if you keep going, you'll learn stochastic partial differential equations.
Okay.
So the work he was doing kept on leading to SPDEs, because I'm not going to say it again. I'm just going to use acronyms.
No, that's fine.
We're techies. We use acronyms. So kept on leading to SPDEs. So that's the first product is we've generalized that into what we call stochastic learning. Now, if you Google that term, you'll see all kinds of things that say they're stochastic learning, and they probably are because nobody owns the definition. We probably shouldn't call it that because people get confused when they look at the
Mhm.
internet, right? But what stochastic learning can do, real high level, is the same kind of training and running of a model that you see in the LLMs. Stochastic learning can do the same kind of work with 3 to 4 orders of magnitude less energy and at that much higher speed. So we think we're on the way with that first step to brain scale. That gives us 3 to 4 orders of magnitude. You need about 8 or 9 from where we're at in the LLM space to get to actual brain scale. So we got 3 or 4 maybe. But maybe we're overestimating is 2 to 3. All right. Um, the
But
next step, yeah,
wait, but even at 1x, if we're talking orders of magnitude, we're already way beyond what LLMs can do.
oh yeah, well we think it's 100 to 1,000 times better.
I mean, as an entrepreneur, how do I get in on this and when is it going to market? I mean, come on. I mean, I know you're still doing all the research and stuff, but I mean, it seems to me there's practical application right now.
Yeah, we're getting to the point where it'll be SL as a service someday soon, right?
Okay.
We're also working with systems integrators because here's the backstory. AI has been out there in the market for 2 or 3 decades
Sure.
with machine learning models of all kinds, just not GPT based or LLM. The algorithm behind LLMs is GPT, generate pre-trained transformer, which Google basically launched in 2015 or 2016, and OpenAI maxed out. But there's lots of other machine learning algorithms out there. And people have been using them in production. You have them all over your life. Well, maybe not off the grid as much, but
I still have a Google phone.
well, and you have a car, and there's
Yes.
machine learning stuff, trained models in that car, and a bunch of other places, right?
Well,
They just
actually,
they're
you
narrow.
just touched on something very, very important. Um, One, quote unquote, AI. I hate that term because it's just so
I know
inaccurate.
it's marketing.
But it's not new. That's number one. Anybody that has brake assist, lane assist, what is it, adaptive headlights, it's all done on a model of, a decision model that's based on math.
Yeah. Either
right?
with training or with rules-based or a combination.
Right.
What people call neurosymbolic now, which is you combine the 2.
That's what we were talking about in the beginning.
Yeah, yeah, but that's my point is that kind of AI has been around for a long time. J4 stochastic learning can make that AI much better than it already is. Even the narrow domain, domain specific AI. Um, and that's really the market for us. The market for us is not to go to OpenAI and Anthropic and say, "Hey guys, all that money you raised to build data centers, you don't need it anymore." They're way too
That's
invested in that approach, right?
well, no, and that's smart because I mean we saw this with return to office, right? Return to office, and there was some of return to office was about productivity, especially if you were not someone like you and I, right? Someone with less experience and who needs that connective tissue to succeed. But a lot of it was just we have an investment in offices. We're not going to let them sit there and be empty, right? So they're not going to abandon their data centers. I mean, at least not initially. I mean, even if you look at a good model would be the manufacturing model, right? I mean, it took a long time for Ford to be like, "Yeah, we're done with Detroit except for R&D."
Yeah,
There's got to be something cheaper. There's got to be something that makes that much more sense.
right, right. And so, yeah, I mean, that's part of it, right? So, stochastic learning, like I said, we think we can help with existing real world AI implementations, not the LLM stuff. Though we could help there too, but I don't think there's going to be interest. Um, but right behind that, and this will torque your brain if I can explain it correctly. Um, there's a math problem called the traveling salesman problem, or
Yep,
TSP.
I know
You can
that.
look up TSP Lib if you want, and you'll see a library of various examples. Um, traveling salesman problem is a specific example of what's called a non-polynomial math problem. And there's an ongoing research problem in math called is the question of whether P equals NP. Do Can all non-polynomial problems be solved in a polynomial time? Does P equal NP or not? Most mathematicians think it doesn't. And there's a subset of this whole area of research that has proven that any NP problem is equivalent to every other NP problem. It's
Okay.
NP complete. So if you can solve TSP, you've solved all NP problems, all non-polynomial. Trust me, the math is there. It's hard. I
No,
studied it in college.
I don't. Yeah, I know the problem, so I get it.
I studied it in college. It's still a problem many years later that nobody solved. There's the Clay Institute has $1 million Millennium Prize out there for solving this, proving it one way or another. Um, it's a problem that shows up in a lot of places. Every logistics problem is a non-polynomial problem, like
Mhm.
assigning airline gates, um, Amazon managing their delivery network, which is a giant, traveling salesman problem, or
Right.
Walmart, or
Well, military.
yeah, well, moving 10,000 troops from one place to another and the supply chains and everything else, right? And so everybody's solving these problems with heuristics and, pruning and best guesses, and they're somewhere between 1 and 10% below the optimal solution. But to calculate the optimal solution for a TSP above like 25 nodes, you can't even do it on the largest supercomputer in the world. You can't do it in a reasonable amount of time, right? And it's not exponential, it's super exponential. It's factorial, basically. So every time you add a node, it's instead of 25 factorial, now it's 26 factorial and then 27. And okay, what if I have 1,000 nodes? Well, good luck. That's how long it'll take to solve it, right?
Right.
And so that's why everybody, uses heuristics, et cetera. And so we think we're on the path to a solution, a linear polynomial time solution for TSP, which means all
Okay.
non-polynomial problems, right?
Well, so
That's
all and correctly deployed, and I'm not telling you your business model, but correctly deployed, you've just solved grocery, airline, automotive, train, freight,
we've made them
being
more efficient. We think we can make them 1 to 10% more efficient, which is worth both billions of dollars and millions of tons of carbon not going in the atmosphere because everything's more efficient, right?
sure.
So there's both an environmental benefit as well as just monetary
Well, I know. Well,
efficiency.
I would argue you're missing one point, and that's time.
Okay, yeah, yeah, as well.
right? Because I mean, that's the one thing we can't get back. It's the one thing we cannot reproduce, which is time. So now you've saved billions of minutes or whatever
Yeah.
of time, not just for people, but for machinery, which then compounds the time savings, right? It's not just that 1 or 10% efficiency, it's everything that happens outside of that.
Like I said, this will torque your brain much more than even stochastic learning will when you think through the downstream consequences of this. So, so we're not quite there. We think we're on the path, but many mathematicians have been on the path for 40, well, several hundred years and haven't solved it. So
All right, but we're also accelerating at a rate that we never have before, right? So when you say you think you're on the path, is this like in your my lifetime, or is this in our
yeah,
grandkids' lifetime?
no, this year. Now
This year.
yeah, let's see, we're at 6 nodes. We think we're going to do the capital tours problem. This is a classic TSP problem, tour the 48 capitals of the
Okay.
lower 48. What's the most efficient route?
Okay.
48 nodes is hard to brute force calculate. In fact, I don't think anyone's brute force calculated it because it takes too long. Like heat death of the universe kind of too long. And
Right.
but we think we'll be able to demonstrate that sometime soon. Now, if we can do that, we think it's generalizable beyond that. But there's a difference between empirically demonstrating a linear, time of, okay, 5 takes this long and 48 takes a linear amount more time versus a mathematical proof that is generalized, right? And so, you know, getting to the proof stage is a different thing than having something that works
Uh,
empirically
Sure.
much better,
Yeah.
right?
Yeah. I mean, it's all great and theory, and then you got to get to practice, right?
Yeah, yeah, yeah,
So,
and productization, and that's why circling back to one, I joined J4 in October because J4 decided it was time to come out of the woodwork and try to productize these things in a general way, as opposed to, hey, let's just play with our fund, all right, our hedge fund essentially.
right.
We've wound down the fund and given the money back to the limited partners, and now we are actually trying to, pivot the company into being a product, a technology product company. Um, Really an AI company when you think about it, because that's the mission is brain scale AI. Take a big step back. If we can solve combinatorial optimization, as we call it, or the traveling salesman problem in a linear amount of time, you're getting closer to what the human brain can do. And Jeff's favorite example is folding your laundry. That is very much a CO or a TSP problem. So the different ways that your laundry can be wrapped up around itself after coming out of the dryer and figuring out
Hmm.
how to unwind it and fold it, you can do that while talking to your wife and watching TV.
And yet, I mean, yeah, I mean, the muscle memory issue, right?
It's a,
It,
it's still, you see all these demos of robots trying to fold laundry and it has to be perfectly presented to them. And they take a long time to get a piece folded, but nowhere close. They're not, and they don't. Oh, here's my favorite example. Let's say you have a robot, a humanoid robot, you want to put it in somebody's house and teach it to do their laundry. Take the dirty laundry from the hamper, put it in the washer, run the cycle, put the soap in and then pull it out, put it in the dryer, and then pull it out and fold it. What if there's a cat sleeping in the hamper with the laundry? Now you and I
well,
know what
yeah.
a 5-year-old knows what to do. Don't throw the cat in the washer.
The robot's going to throw a cat in the water.
Well, it doesn't know what cats are. It doesn't have any, world model, any common sense. So it's just going to shove stuff in and shit happens. At what point will we be comfortable putting a humanoid robot like that into a house and have it not mess up? Stuff that a 5-year-old would not mess up, right?
Well, I mean, that's a great question because, I mean, if you think about it, knowing what we know about robots today, I mean, they're very good at very specific things. Roomba, right, is, I mean, I never owned one, but it did its purpose. Or they've got a nose that mows a lawn,
Yeah,
right?
yeah.
But
Those are
you
more
got to
dangerous
start,
than the Roomba, right?
but what are you going to do when you have a kid, a toddler, right? Who's going to want a machine who is at least as strong as a full grown man, at least, that cannot process certain variable metrics around their toddler,
Yeah.
you
But
know?
a 5-year-old's gonna know not to hurt the toddler. Well, unless he's, you know
He's gonna know that he shouldn't hurt the
Yeah,
toddler. Let's put
yeah,
it that
somehow
way.
he already knows
But
that.
he doesn't necessarily know not to put a key in an outlet,
Yeah,
right?
yeah.
All right, so we're getting toward time here. What is our? I mean, there's a lot of takeaways we have because this has been a fantastic conversation. But for you, for J4, what the future holds in your mind, what's your takeaway?
Yeah, I mean, like I said, we want to get to brain scale AI. We probably aren't going to be building the robots or the embodied AI on various edge cases, whether it's vehicles or robots or whatever. But we're probably going to be providing that technology to companies that are doing that. Um, and for us, that's what we're trying to get to is be kind of the technology behind a lot of these implementations. But we're not close to brain scale. There's other things that have to happen. I mean, stochastic learning and combinatorial optimization don't get you all the way there. There needs to be more, and we think we have some ideas behind that. We're just not ready to talk about them. That could get us all the way to brain scale. But right now we're at the beginning of this. We need to productize what we have. Get to a useful revenue state. We're generating revenue now from customers in media and entertainment because we can help movie production be a lot more efficient. If you listen to James Cameron, he even talks about, hey, we should use AI to make movie production.
Right. Yeah.
Oh,
Yeah. So
yeah.
that he can, because they can't afford, or they can, but it's not as profitable to make the Avatar series anymore because of just
If,
what it takes.
if you look at how movies are actually made, there's so much inefficiency and everything, and that you can use AI to orchestrate the processes much better. Not, yeah, you can use AI to generate video and CGI and all that. That's kind of a well-known thing. We're talking about the back side of the house, the back of the house in terms of making a movie. We're really good at that. And so we've got a few production studios, Hollywood production studios that are paying us money to help them, basically. And some may invest. We have, the opportunity in finance. Yes, we shut down our fund, but we keep developing the technology um, where we can either, help somebody who wants to use our technology to run their fund to help make trade decisions and then, pay us fees in some form or another. Um, we could run a proprietary trading desk. We can sell our signals. We can do lots of things. All right. So we'll probably do that to generate revenue as well. We just did a run, I think, looking at, you do a test run, you take data from like the last N weeks of trading a particular security. In this case, we did the Standard& Poor Index, the SPY. Did a run of like 5 weeks of trading on SPY with the latest iteration of our stochastic learning adapted into that trading scenario. And it generated some absurd returns, like 20% on 5 weeks of trading. Yeah.
Feel free to pass that along.
Well, look, it's not verified in the sense that, you do this test stuff, but if you get deep into how markets work, executing a trade at the price you want is not actually a guarantee,
That's
right?
correct.
So you put the trade in, and if it's too big, it has to be chopped into pieces, and each piece will go to a different price. And so there's all this stuff that actually goes on where you think you want to trade at this price, but by the time the trade gets in, the price has changed and it's an auction anyway. And so running simulations is not the same as running it for real. And so we're getting closer to running it for real to see how much of a haircut we have to take off of that 20% return in 5 weeks of trading, which is like 300% a year, which is completely insane. So
Yeah, I mean, like I was saying, I can run the math. Please feel, but, I mean, right now I'm doing okay because AI is driving those 7 companies that run the stock market, right?
yeah, yeah, it's
But
30% of the S&P or whatever it is. Yeah.
yeah, I wouldn't mind having slightly more reliable returns because sometimes, you open up the portfolio and you're like, yeah, and then the day later you're like, oh God.
Live
So
by the sword, die by the sword. That's right.
that's
I mean,
exactly right. All
but
right,
anyway, so
folks. Oh,
we have those kinds of avenues for revenue, plus the systems integrators who want, better AI for their customers, where, they're all helping their customers manage their data and use AI to do better things with their data. But the AI they're using is often just out to the LLMs.
right, which
And
is
we, yeah,
eventually that's going to peak into a cost problem.
yeah.
So,
And they're not that great. They make shit up. They get stuff wrong.
oh, I mean, you can't get. Um, Actually, I was talking with Peter Corliss about this yesterday. He was running, the one that people use to write a lot of code. I can't remember. can't
Claude
remember what it's
Code,
called,
probably,
Claude Code, yeah, and
from
he was using
Anthropic.
Claude to, he wanted to see if he could get it to correctly, with a very specific prompt, build a D20, a 20-sided die.
Right, right.
And he didn't know what to do. In fact, it was really tweaky. And I took the exact same prompt and gave it to Gemini. Gemini did a much better job, but it was still wrong in terms of like where the
Yeah,
numbers were and stuff.
yeah.
All right, folks. Well, this has been another More Than a Refresh with Kevin. Sorry, Kevin Jernigan. Got my brain going all kinds of places.
Sorry.
With J4, they're doing some very interesting stuff. They've got a new, it's not a new term, but I have a feeling in the next 18 months it will be the term brain scale AI. And with that, Kevin, thank you so much.
Thank you, Jay. This has been great.